everyone, I'm Suman.
I'm Mayuri.
And I'm Serena, and today we'll be talking about the scientific method.
So, most people think scientists simply say, hey, I wonder what would happen if we ran electricity through a particular part of the brain. While that could be fun to see, it's not necessarily science. Can anyone tell me why?
Hey Suman, so I think the goal of science is to create larger theories to explain how the world works.
Exactly. And we do this through the scientific method. Mary, can you explain the scientific method?
Sure. You generally have the following steps. You ask a question, you make a theory, the theory makes a prediction, you build an experiment that can test the theory, you get your result and interpret it. The coolest thing about science is that it works no matter what because science is a process.
Right. Scientists believe planets revolve around the sun because that's a process that they discovered.
The world could have been very different depending on what processes were discovered. Magic could have been real and studied by scientists.
In this video, that is exactly what we're going to do. We're going to study magic from the world of Harry Potter.
We're even going to theorize how magics and spells work.
Throughout this video, we'll be focusing on predictions. For science to work, we need to have at least two theories on how something could happen. Alright, so we'll be talking about spellcasting. So magic in the wizarding world of Harry Potter starts on verbal command and with the correct sequence of movements of a wand. So let's watch this video to understand how witches and wizards cast spells.
With Lego Harry Potter, there is new magic to discover.
One of a wizard's most rudimentary skills is levitation, or the ability to make objects fly. Do you all have your feathers? Good. Now, don't forget the nice wrist movement we've been practicing. The swish and flick. Everyone? Swish and enunciate. Wingardium Leviosa. Off you go then.
Wingardium Leviosa. Wingardium Leviosa. Stop. You're going to take someone's eye out. Besides, you're saying it wrong. It's Leviosa, not Leviosa. You do it then if you're so clever. Go on. Wingardium Leviosa.
Oh, well done. See here, everyone. Miss Grange has done it. Splendid.
Wingardium Leviosa.
Well done, dear.
I think we're going to need another feather of it.
Alright, so notice how every witch or wizard moved their wand differently, either pointing down constantly or going up and then down. And each one pronounced the spell differently, like Leviosa or Leviosa. But they all knew that the spell was meant for making the feather to fly. So, what helps with casting a spell? With me, we will focus on whether the witch or wizard needs to know what the spell will do in order for the spell to work. So, what are some possible hypotheses that could answer this question?
One hypothesis is that a witch or a wizard must know the intent of the spell in order to cast it.
Or the opposite may be true. The alternative hypothesis is that a witch or a wizard can cast a spell without knowing what the spell does.
In order to test these hypotheses, let's come up with an experiment to test them out. Let's say we want to cast a spell that makes a bat, the animal, glow. And the words to the spell are Floro Chiro. What are some possible experiment ideas we can come up with? Pause the video to think of some potential experiments. All right, did you think about what we could do with this particular spell? Let me show you how I made my experiment. So one way to see how knowledge plays a role is in the effect of a spell is by giving witches and wizards the spell and tell them that it makes glowing bats without specifying what bats mean, makes bats the animals glow, makes bats the sports equipment glow, makes a glowing bird, just makes a bird, makes a glowing cloud, makes people forget things, or just simply don't tell a witch or wizard what the spell does. So by seeing the spell effects of each meaning that we give to a witch or wizard, we will be able to answer more confidently whether knowing the intention of a spell is what helps the spell to work or not. If the spell works when the witch or wizard knows that the spell makes bats the animals glow, which is the correct intention, that means Mayuri's hypothesis was supported. If the spell works when the witch or wizard doesn't know the true purpose of the spell, that means that Serena's hypothesis was supported. Thinking about these two predictions can help explain whether intention matters in spellcasting or not.
So, while you heard Sumin ask a question about whether witches or wizards knew the intent of the spell and how that affected the casting of the spell, I'm going to choose to look at how the way we say the spell affects the casting. In this new section, we will study the magic control system.
Our research question in this section would be, how does the magic control system understand words?
So the first hypothesis is that the magic control system doesn't work if the syllable, inflection, or the length of the syllable in the magic spell is changed. And of course, the alternative hypothesis is the opposite. The magic control system still does work even if a syllable, inflection, or the length of the syllable in the magic spell is changed. So, how do you think we can test for this? Pause the video and take a moment to think about this.
So to test this hypothesis, we will have to use the fishing expedition method. This is when you end up trying a bunch of random things to see if there's a pattern no one has observed yet because you just don't have enough information to create a theory.
Let's start off by changing one syllable in a spell, so we can keep coming up with variations in each of our spells. We can start off with a relatively small change in the syllable, such as going from Wingardium Leviosa to Wingardium Leviosa. Then we will increase the variances.
I guess the next spell we could try is saying something like Wingardium Leviosa. And then we keep changing that one syllable of our choice until we have something completely different, like Wingardium Leviosa.
And it's definitely important to write down each spell and then note at which variation point, Wingardium, Wingardium, which point the spell stops working.
We should also test for the inflection to see if that has anything to do with what the magic control system can understand. For instance, instead of saying Wingardium Leviosa, we can say Wingardium Leviosa, and so forth.
Exactly. And like Suman said, we should keep noting which spells worked and which didn't. Because this way we can see how much we can stray from the correct way of saying the spell to see how the syllable affects the magic control system.
We should also test if the length of the syllable makes a difference. So, for instance, does extending parts of the syllable affect whether the magic control system can understand the spell?
For example, we pick one syllable again. In this case, I chose ga. And in the spell, Wingardium Leviosa, I'm going to extend the ga syllable and say it like this. Wingardium Leviosa.
If it does make a difference, is it the individual length of the syllable or the ratio of syllables that makes a difference? For example, Wingardium Leviosa might work when the previous one does not.
So in other words, we're asking if we extend all of the syllables, then can the magic control system understand our spell?
So once we collect all the data on these different variations of the syllable, we will be able to tell what affects the viability of the verbal spell.
So how do we determine which hypothesis is correct or supported? Is one completely supported or is both partially supported? If changing a syllable only slightly doesn't affect whether the spell works, then we would say that our second hypothesis, that the magic control system is not dependent on the complete integrity of the syllables, is correct. And if the ratio is what matters, then our second hypothesis is again supported. Remember that hypotheses can be partially supported.
So now we're going to apply the scientific method to a very intriguing and mystifying question, the idea of mental magic. In Harry Potter, we saw that wizards turned into animals, but still thought like wizards or witches. Here's a video to show this.
Amazing. Can you imagine the look on McGonagall's face if we were late? That was bloody brilliant.
Thank you for that assessment, Mr. Weasley. Perhaps it would be more useful if I were to transfigure Mr. Potter and yourself into a pocket watch. That way one of you might be on time.
We got lost.
And perhaps a map. I trust you don't need one to find your seats.
Based on what we have learned so far, let us try and derive some hypotheses. What are some hypotheses for why in Harry Potter, wizards retained their intelligence even when they transformed into animals?
So one hypothesis could be that the animal brain acts as a messenger to the thoughts of humans. So it receives those messages as the animal and decodes these messages to perform human-like behaviors.
Another hypothesis could be that the brain of the animal resembles those of humans, and because the wizard, who used to be a human, transformed into the animal.
Once we have created our hypotheses, we can derive a possible answer by testing our hypotheses. But before that, we must use our hypothesis to create a prediction regarding what the outcome of our test will be. If we test our hypothesis and then try to explain our results after, then that is not good science. So, what predictions can we make?
My hypothesis, hypothesis one prediction that I can make is that animals will take more time to respond to a signal than a human brain would. This is because if the animals must decode their messages to think like humans, they would need this extra time to decode the message compared to humans who do not need to decode any signals.
And for my hypothesis, hypothesis 2, if the transformed animals and humans had similar brains, one prediction I could make is that the brain regions activated in animals would be similar to the brain regions activated in humans when doing the same activity.
Great! So now, following the scientific method, we have made our predictions regarding what we would expect for each hypothesis under certain conditions. Now, what is the next step of the scientific method? It's simple. We run our test and then see whether it matches our prediction.
So, for hypothesis 1, we could record the time taken for animals to respond to a signal and compare that with those of humans.
And for my hypothesis, hypothesis 2, we could train animals and ask humans to do the same task, like looking at specific patterns, and record the brain activity for animals and humans.
Finally, we will interpret our results. If our results match our prediction, then what do we learn? Pause the video for a moment to think about this.
We learned that our hypothesis is not incorrect. This means that animals could think like humans due to our hypotheses. And therefore, we may have a theory about why animals can think like humans in Harry Potter.
But we can never be sure from just one test. We would still have to perform many different tests to actually conclude that our hypothesis is correct. But still, we definitely learned something new.
So, what did we learn today? We learned how to utilize the scientific method to test some of the mysterious things in Harry Potter. We used the 5 steps of the scientific method. Do you recall what those were? So here are the 5 stages we used today. First of all, we asked a question. Then we came up with a theory, and then we made a prediction. After that, we built an experiment to test that theory. And the next thing that we would do is obtain the results and then interpret them.
If our results match our hypothesis, then our hypothesis may be supported. But if not, then we must reject our hypothesis and try something else. This is how we practice good science. Thank you guys for listening to this video. I hope you guys enjoyed, and until next time, we will see you guys later.